An asteroid has a 1 in 83 chance of hitting Earth in just over 7 years. While most space rocks pass by harmlessly, this one, known as 2024 YR4, which is about half the size of a football field, is too close for comfort. An next report, Tanigimo.
An asteroid hurtling towards Earth is something real-life scientists are preparing for at NASA. They are refining their plans because, in a few short years, a space rock could come quite close. Apophis is the closest thing we know about to an asteroid that could really give us a bad day. This thing would wipe out a city without a problem. Astronauts and space scientists are actively figuring out how to address this threat. The countdown has begun, with NASA scientists now paying serious attention to a possible asteroid impact on Earth. As we already know, the asteroid Apophis will pass very close to Earth in the next few years, and astronomers around the world are waiting to capture this rare astronomical event. However, recently, scientists have expressed concern. NASA has revealed that they are conducting an exercise to prepare for an upcoming devastating asteroid impact. They also warned that recent calculations have shown an asteroid is heading towards Earth, with a 72% chance it will hit our planet. In this video, we will find out why NASA scientists are suddenly worried about an impending asteroid impact and what steps they have taken to avoid this catastrophic disaster. NASA wants to be able to get a spacecraft out there weeks to months in advance to get a look at Apophis before its close encounter with Earth. Apophis is an asteroid that was discovered on June 19, 2004 by astronomers Roy A. Tucker, David J. Tholen, and Fabrizio Bernardi. It measures approximately 370 meters in diameter, about the size of 3.5 football fields. This makes it a relatively large asteroid, and if it were to collide with Earth, it could cause significant damage. Apophis is expected to make a particularly close approach to Earth on April 13, 2029. This date is significant because the asteroid will come closer to Earth than many of our satellites that orbit the planet. At its closest, Apophis will be within about 31,000 kilometers of Earth's surface. To put that into perspective, that's roughly 1/10 the distance between Earth and the Moon. This will be the closest that an asteroid of this size has come to Earth in recorded history, and it will be visible to the naked eye in some parts of the world, appearing as a fast-moving point of light. As of now, Apophis is far from Earth, traveling through space in its orbit around the Sun. Its exact position changes constantly due to its high speed and the gravitational influences of other celestial bodies. Scientists track its position using powerful telescopes and radar observations to ensure they have accurate data on its trajectory. When Apophis was first discovered, there was significant concern that it could collide with Earth in 2029. Initial calculations suggested a small but real possibility of impact. However, with more observations and refined calculations, scientists have determined that Apophis will not hit Earth in 2029. The risk of an impact in 2029 has been completely ruled out, and current models show that Apophis will pass safely by Earth. However, its close approach will provide scientists with a unique opportunity to study the asteroid up close, which could help improve our understanding of such near-Earth objects. While Apophis will not impact Earth in 2029, scientists continue to monitor it closely. There is a possibility that its orbit could be slightly altered by Earth's gravity during the 2029 encounter, which might affect future approaches. One particular date of interest is April 13, 2036, when Apophis will make another close approach. If Apophis's orbit is significantly affected by Earth's gravity in 2029, its next close approach in 2036 could pose a threat to Earth. But the question is, are we prepared for this? If humans identify a dangerous asteroid long enough before impact, we could theoretically do something to divert it. NASA recently conducted a hypothetical exercise to assess the planet's preparedness against an asteroid impact. The exercise simulated a scenario where an asteroid, previously undetected due to its orbit around the Sun, was on a collision course with Earth. The asteroid, estimated to be large enough to cause substantial regional damage, was projected to strike the planet in 2038. Participants were told the asteroid was between 60 and 800 meters across, with a 72% chance of hitting Earth. With 6 months before more details about the meteor could be obtained from telescopes, despite the 14-year warning time, the exercise concluded that humanity is currently ill-equipped to prevent such a disaster. Initial observations were not sufficient to determine the asteroid's size, composition, or precise trajectory, complicating matters. The asteroid was expected to pass behind the Sun, rendering it unobservable for a critical 7-month period. The exercise highlighted several key challenges in planetary defense. One of the primary issues is the limited capability to deflect or disrupt an asteroid on short notice. Current technologies, such as kinetic impactors or nuclear devices, require years of development and testing before they can be considered viable options. Additionally, international collaboration and coordination are crucial, as the impact of an asteroid would have global consequences. The recent exercise serves as a wake-up call for the global community to prioritize planetary defense. It is a reminder that the threat of an asteroid impact, though infrequent, is real and requires proactive measures to ensure the safety of our planet. Earth's most recent brush with asteroid danger was 8 years ago when a space rock the size of a 6-story building came seemingly out of nowhere. The Chelyabinsk meteor was a small asteroid, about the size of a 6-story building, that broke up over the city of Chelyabinsk, Russia, on February 15, 2013. The blast was stronger than a nuclear explosion, triggering detections from monitoring stations as far away as Antarctica. The shockwave it generated shattered glass and injured about 1,200 people. Some scientists think the meteor was so bright it may have briefly outshone the Sun. The incident was another reminder to space agencies about the importance of monitoring small bodies in space that could pose a threat to Earth. Learning from this, we have recently successfully tracked an asteroid impact. A recent encounter with a small asteroid over Germany, which was successfully predicted and tracked by the agency's Scout Impact Hazard Assessment System, demonstrated the capability to monitor such objects. The asteroid, designated 2024 BX1, disintegrated harmlessly in Earth's atmosphere but served as a practical demonstration of NASA's planetary defense capabilities. However, the recently conducted hypothetical international planetary defense exercise raises concerns over how we would deal with a real asteroid crisis. NASA's Planetary Defense Officer Emeritus, Lindley Johnson, concluded that we need as much information about an asteroid's size and trajectory as possible to avoid the practical problems created by uncertainty. The exercise underscored the importance of early detection and accurate tracking of near-Earth objects, NEOs. One of the critical takeaways was the need for advanced space-based telescopes and ground-based observatories to identify potential threats long before they become imminent dangers. Early detection allows for more time to develop and implement mitigation strategies, whether through deflection, disruption, or other means. NASA's upcoming NEO Surveyor mission, set to launch in the near future, aims to address this gap by identifying and characterizing potentially hazardous asteroids and comets. This mission will significantly enhance our ability to detect and track NEOs, providing crucial data for planetary defense efforts. Another key challenge highlighted by the exercise is the development of effective deflection technologies. While kinetic impactors, such as NASA's Double Asteroid Redirection Test (DART) mission, which successfully altered the orbit of a small asteroid moonlet in 2022, show promise, they are still in the experimental stage. Other proposed methods, like gravity tractors or nuclear explosive devices, require further research and international consensus on their use. The exercise revealed that even with a 14-year warning, current technologies and infrastructure are insufficient to reliably prevent a catastrophic impact. This has spurred calls for increased funding and collaboration to accelerate the development of planetary defense capabilities. International cooperation is another critical factor in addressing the asteroid threat. An asteroid impact would not discriminate between nations. Its effects would be global. Therefore, a coordinated global response is essential. Organizations like the United Nations Office for Outer Space Affairs, UNUSA, and the International Asteroid Warning Network, IAWN, play vital roles in fostering collaboration among nations. The hypothetical exercise emphasized the need for clear communication channels, shared resources, and unified strategies to ensure an effective response to a real asteroid threat. Public awareness and education are also crucial components of planetary defense. While the likelihood of a catastrophic asteroid impact in any given year is low, the potential consequences are severe enough to warrant proactive measures. Educating the public about the risks and the steps being taken to mitigate them can help build support for planetary defense initiatives. It can also reduce panic and misinformation in the event of a real asteroid threat. The Chelyabinsk meteor event in 2013 served as a stark reminder of the dangers posed by even relatively small asteroids. While the 2024 BX-1 asteroid's harmless disintegration over Germany demonstrated progress in detection and tracking capabilities, it also highlighted the need for continued vigilance. Small asteroids, like the one that caused the Chelyabinsk event, are more challenging to detect due to their size and speed, yet they can still cause significant damage. This underscores the importance of improving our ability to monitor smaller objects while also preparing for larger, more destructive threats. Looking ahead, NASA and other space agencies are exploring innovative solutions to enhance planetary defense. Concepts like laser ablation, where a high-powered laser is used to vaporize part of an asteroid's surface and alter its trajectory, are being studied. Additionally, advancements in artificial intelligence and machine learning could improve our ability to predict asteroid paths and assess potential risks. Collaborative efforts between governments, private companies, and academic institutions will be essential in driving these innovations forward. In conclusion, while the threat of an asteroid impact is rare, the potential consequences are too significant to ignore. The recent hypothetical exercise conducted by NASA and its international partners has highlighted both the progress made in planetary defense and the gaps that still need to be addressed. Early detection, advanced deflection technologies, international cooperation, and public awareness are all critical components of a comprehensive planetary defense strategy. As we continue to explore and understand our solar system, protecting Earth from potential asteroid impacts must remain a top priority. The lessons learned from exercises like these will help ensure that humanity is better prepared to face this cosmic challenge in the future. It also indicates that there is still a lot of work to do in terms of international preparation for these types of celestial disasters.